Hello everyone and welcome to the Informatics Practices class of Standard 12. In our today's discussion of computer networks, we will be looking into the different network topologies as per the syllabus of CBSE. We will also talk about the URLs and the various parts of URLs. In our previous class, we have already discussed about the networks, advantages and disadvantages or needs of networks, the different types of networks around us, and the various network devices used to form a network. Let us start our today's class with the network topologies. Before we start away with this, we have a question for you. The question is, can you place 10 coins in such a way that they line in 5 straight lines? And on each of these lines, there are exactly 4 points. Difficult question, I suppose. Will take a few moments of our life and will definitely involve some pencil and paper work too. So you have a few minutes to go through this, and in the meanwhile, we'll also cover the topics of network topology. In the topics of network topologies, we'll first know what are exactly network topologies. So, network topologies are nothing but the arrangement of nodes within a network. When we say arrangement, we are talking about both physical and logical arrangement. And nodes are nothing but the different devices that are associated and present in a network. A node may be a computer, a node may be a printer, or a node may be a scanner, or it may be acting as any desktop device. Let us look at the first topology as per us. In star topology, each node is directly connected to a hub or switch. We may also say that the nodes are connected to a concentrator. Hubs are sometimes called as concentrators because they are helping in concentrating of networks. If any node sends information to some other nodes, the same signal is then sent to switch. Because there is a dedicated connection between the server and the nodes, there will be no problems in communication between the server and the different workstations. Additionally, the speed of communication will also be high. In case of star topology, it is very easy to install. Had it not been easy to install, no one would have taken or used star topology. Star topologies are also very efficient as compared to bus topologies, which we will be looking after some time. When we talk about fault diagnosis in this topology, it is pretty easy if the fault is in a particular node. Assuming that over here we have this as our server and the other 4 devices as the nodes. So if the problem is with any of the nodes, then it is very easy to diagnose the fault. We may just unplug the device from the central hub or concentrator, and then very easily the network will stop showing any error of communication failure. But if the error is within the server itself or within this hub, then the entire network shuts down. This is also called as the central node dependency, which we have discussed in our disadvantages of networks in the previous video. Or additionally, when compared to something like a bus topology, star topology will also require more cable length. Why so? Because the star topology has one connection per client. So even though 2 clients are placed one after the other, there will be 2 different nodes or 2 different wires for each of the clients. Next, coming to our topic of bus topology. In bus topology, there are nodes that are connected to the main cable which is also called as the backbone. If there is any node which wishes to send its information, then it needs to send the information through this main backbone. How is the information sent? Suppose the information is being sent from here to here. Then the information generates through this pass and will be splitted in both the directions, this and this. As there is a terminator over here, it will not let the signal pass through it, or it will not let the signal be reflected backward. So the work of the terminator is to absorb the signal so that it does not travels back within the network. When the file or when the signal travels within this, it will travel to each and every device which is present within the network. That is, it will travel to this device, to this device, to this device, to all the other nodes that are present within the network. Hence, even if they do not intended to receive this signal, they still have this signal. So the nodes in bus topology should be intelligent so that they are able to discard the signal if it is not meant for them. Again, there is another problem with bus topology. If it is used for small number of computers, then it is good. But if we wish to use it for a large number of computers, then the wait time for sending of signals will increase very much, because if one device is sending signals, then the rest of them should be waiting for their turn to send their messages. Expanding a bus topology is very easy. Why so? Because you only need to remove this terminator and then you can easily send your signals through, or by adding up more wire length from this place, and then this terminator can be placed at the end of the other wire. But there is always some problem, as each and every cable has its own capacity or length to transmit data. So for example, if we are using a twisted pair cable for transmitting the data, the average length of transmission for signal is 100 meters. And if the length of two different nodes is greater, or the distance between two different nodes is greater than 100 meters, we will not be able to send the signal perfectly, or there may be some noise while transmission of this signal. As a result, if we are using bus topology for long distances, then we will have to add repeaters at optimum places. This will again add to the cost of the network. Other than this, there is nothing in the bus topology which is costly, which makes it pretty useful for organizations which do not have much funding for creating their networks. Bus topology has another advantage, that even if a single node, if any nodes fail, there is no problem in the network. But the diagnosis of this fault takes a lot much of time. Hence, bus topology is very difficult to diagnose. Let us move towards our third topology, named as the tree topology. The tree topology is a combination of bus and star topology. As a tree has its trunk, the tree topology has its backbone, as it was there in the bus topology. And as in star topology, there are multiple nodes and networks formed of star topology. So it is a combination of both those topologies. Tree topologies are generally used when in large organizations, and additionally where expansions of work may be very much possible, because tree topology is very easy to expand. Next in our topic today is mesh topology, the easiest of all and the most convenient and reliable of all. Why do we say it as the most reliable of all? Because in this topology, each device is connected to all the other devices via a dedicated cable. So suppose there are 4 computers over here, A, B, C and D. And if one of the nodes connecting A and B fails. So data can still be transferred from A to C via B or via D, whichever way you feel useful or the network router feels useful. Hence, mesh topologies are the most reliable of all, although it is the most difficult to set up, because in over here you will require a lot many wires, and those many wires also needs to be arranged or co- uh, kept together. Hence, mesh topologies are very difficult to install as well as very difficult to expand, and hence are not good for very large number of nodes. This is all from our topics of topology. We will now move towards our topic of URL. URLs are nothing but uniform resource locator. We have been studying about URLs right from our lower classes. Each website or document on the internet has a URL, and each URL is mapped with an IP address over the network. Hence, each URL is unique because of its IP address. A URL has basically three parts: the protocol, the domain name, and the path. Over here, as you can see, this is our protocol, this is our domain name, and this is our path. So the protocol suggests that this type of data is being transferred, or this type of communication is being followed by this website, which has been registered by a particular person. As deep as you go into a website, the path of that particular website goes on. The protocol declares how your web browser should communicate with a web server, and hence HTTP is generally the protocol you may see on the internet. Other than that, HTTPS, FTP, SMTP, and Telnet protocols are also there. The HTTP protocol stands for Hypertext Transfer Protocol. As the name only suggests, this protocol is used for sharing of or for communication of hypertext. Hypertext is nothing but text along with some multimedia, that is music, video, images, and whatnot. HTTPS is just a secure mechanism of transferring of hypertext, which is generally used in banking applications and websites, or wherever security is of utmost use. So generally on a login page, you will see a HTTPS protocol being followed. FTP stands for File Transfer Protocol. So when you are transferring file from one device to another, you are generally following the FTP protocol. SMTP protocol is followed in mail servers, and it stands for Simple Mail Transfer Protocol. And Telnet protocol is used while doing remote access to while taking remote access to another machine. So devices like TeamViewer are using Telnet protocols. This is it from our today's class, and we will now talk about the answer of the question which was asked to you before this class. So we will again come to the question. The question suggested, can you place 10 coins in such a way that they lie in 5 straight lines? So you need 5 lines, and you have to form those 5 lines using those 10 coins. And on each line, there should be exactly 4 coins. So you need to have 4 coins in exactly each line. One of the possible answers for this is this. How many other answers can you think about? Please let me know on my email, or you can always drop me a message. Thank you so much. Have a nice day.